My dear students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the chapter Newton's laws of motion. This is part 13 of the video. Kindly go through the previous videos also so that you can understand the problems very clearly. This is the first problem of part 13. As shown in diagram, spherical object of mass m, this is mass m, and radius r is suspended by strings of length L. Okay, find tension and normal reaction. Okay, now you are supposed to find tension and normal reaction. Now this is the string which is having tension T. This is the length of the string. Okay, now here radius R is there. Okay, and now here also radius R will be there. Okay, let this distance be T, and let this angle be theta. This is the length of the string. This is radius R, which is given. Okay, and radius R this is, and this distance I have taken D. And what is weight? Weight is equal to m into g. What is the mass you have given? Capital M into g. Now we are supposed to calculate the tension in the string and normal reaction. Normal reaction will be always acting perpendicular to the surface, that is this one. This is normal reaction. This is tension T. Now if I observe, these two are what? These two forces are perpendicular. Okay, therefore we have to use what? Parallelogram law. This we have seen in the previous videos also. Parallelogram law. Okay, now what I can write? I can complete the parallelogram like this. This is normal reaction. This is normal reaction. This is mg weight, and this tension T. All these three forces are in the same order. Okay, since the system is in equilibrium, forces are balanced, and moreover two forces are perpendicular. Okay, now we can use what? Parallelogram law that we have seen in the previous videos also. Now this angle theta with the vertical, this is theta. Now we can find out normal reaction and tension. First let us find the value of tan theta. What is tan theta? Is equal to, that is opposite by adjacent, which is opposite, that is n divided by adjacent, that is perpendicular by base, that is mg. Therefore n is equal to mg tan theta. N is equal to m into g. What is tan theta? From this you can write tan theta is equal to how much? Tan theta is equal to r by t, opposite by adjacent, that is perpendicular by base, mg into r by t. This is the value of the normal reaction. Now let us find tension. Let us find cos theta. What is cos theta? Is equal to adjacent by hypotenuse, that is base by hypotenuse. Therefore I can write T is equal to what? mg by cos theta. What is cos theta? From here, okay, cos theta is equal to adjacent by hypotenuse. Hypotenuse means what? L plus R here. Okay, this whole thing. Okay, L plus R. Cos theta is L plus R. Therefore mg divided by, this is L is what? Length of the string plus radius. Okay. Now cos theta is equal to d by L plus r. Okay. D by L plus r. Therefore, I can write this as what? T is equal to mg into L plus r by t. By t I can write t is equal to cos theta is what? D by L plus r. Okay. So L plus r will go to the numerator, mg L plus r by t. Okay. This is the value of the normal reaction, equation of normal reaction, and this is the equation of tension in the string. Okay. Now we have found tension and normal reaction. Let us go to the next problem. Let us do one problem on the same thing. Uniform sphere of weight W and radius 3 meter. Okay. Now radius is how much? 3 meter they have given. Okay, this is 3 meter. This is also radius is what? 3 meter. Is being held by a frictionless wall as shown in the figure. The tension in the string will be how much tension? Length of the string. Length they have given this as 2 meter. This is 2 meter plus 3 meters 5. This is 4, and this will be how much? If you use Pythagoras theorem, this will be 4 meter. This angle is theta. This angle is what we have to find. The tension in the string will be. What is the formula for tension? Just now we calculated. Okay. T is equal to what? Mg into T is equal to mg into L plus r by t. T is equal to mg into L plus r by t. Okay. In place of mg, they are writing W. Okay. W into L is how much? Length of the string, that is 2. Radius is how much? 3 divided by this d, distance is how much? D is equal to, okay, this is R. Okay, this is R, this is L. Okay. D is 4. That is T is equal to 5W by 4. 5W by 4 is the right answer. Hope you have understood this problem also. Let us go to the next problem. If system is in equilibrium, find relation between m and m. Where is m? This is m. Okay, this is weight is mg. This is mg. This is small mg here. Okay. Now we are supposed to find the relation between this capital M and. Now if I observe this one here, this is capital M, weight is mg, the pulley is like this, pulley is like this, okay? Strings are connected like this, okay? Tension will be there here, tension will be there. This angle is theta. This angle is theta. Okay. Now draw a horizontal line. Resolve these two forces. Okay. That is, this will be what? T sin theta. T sin theta. This will be T cos theta. T cos theta. Okay. We are resolving these two forces. That is T cos theta, T sin theta, T sin theta, T cos theta. This gets cancelled. Okay. This gets cancelled. Now T cos theta will be how much? 2T cos theta. Now we are not using Lami's theorem here. We are using force balance technique. Okay. That will give, because we have the magnitude of two forces is same. Okay. And none of them are in perpendicular. Okay. This is, see here, T here. This T is there. this T is there. Okay, magnitude of these two forces is same, and one more force is mg. Okay, none of them are in perpendicular. Therefore, we did not use Lami's theorem. We did not use what? Parallelogram law. We have to use force balance technique. Therefore, here I can write 2t cos theta is equal to what? Capital mg. What is tension in this string? T. This is T. This is T. Okay. This is T. Okay. This is angle that I have written here, theta, and this is also theta that I have shown here. Okay. Tension T is equal to what? Small mg. Therefore, you can write 2 is equal to small mg cos theta is equal to capital mg. G gets cancelled. So m is equal to 2m cos theta is the relationship between what? Capital M and small m. Hope you understood this one. Okay. Let's go to the next problem. It is saying a string of negligible mass. Okay. Going over a clamped, this is a clamped pulley of mass small m. Okay. This is not ideal pulley. Okay. This pulley is having mass m. Okay. Therefore, here weight will be what? Mg. Here weight will be capital Mg, and this will be tension in the string, that is T is equal to what? Mg. Okay, this tension will be there. Okay. Now, of mass m supports a block of mass m as shown in the figure. The force on the pulley by the clamp is given by the force on the force on the pulley you are supposed to calculate. Now, observe here, we can use parallelogram law because two forces are perpendicular. Now, let us complete the parallelogram. This is tension T. Okay. Tension T. Now you are supposed to find the force. That is what? The force on the pulley by the clamp is given by, okay, that can be considered as T dash. Now, what is the weight on the pulley now? Weight at the center of the pulley will be what? Mg plus mg. Therefore, capital M plus small m into g. Okay, this force is in perpendicular with this T, tension T. Okay. Now, if I write the forces at the center of the pulley, mg plus mg, that is capital M plus small m into g, and then this is the torque T, and this is T dash is the force on the pulley we are calculating. Okay, force on the pulley by the clamp is given by, okay, T dash. Now I can write what? T dash is equal to what? T dash the whole square, the square and the hypotenuse is equal to sum of the squares on the other two sides, that is T square plus of capital M plus m small m g the whole square, right? Therefore, T dash is equal to what? Square root of T square plus of m plus of m g the whole square. What is T? T is given by what? Mg. Okay, T is given by what? Mg. Therefore, I can write this as what? Square root of mg the whole square plus of capital M plus small m g the whole square. I can take g outside the square, that is m square. I can write m square plus of m plus m the whole square g. Now it is the right option here, m square, okay, m plus m square. Hope you understood. This is the right answer. Okay. Now kindly go through the problem so that you can understand all the things very clearly. We have done. This is the first problem, okay, to find normal reaction and tension, and this is the numerical based on how to find the tension in the string. Directly use the formula, you will get 5W by 4. And the next one is the relationship between capital M and small m, and then we are calculating the force on the pulley by the clamp is given by T dash is equal to square root of m plus m the whole square plus m square. Students, hope you might have understood all the problems very clearly. Kindly go through the problems once again, practice all the problems. If you have liked this video, kindly share with your friends, ask doubts in the comment box. Do not forget to subscribe for my channel and like the video. I wish you all the best for your KCET, NEET and IIT JEE examinations. Thanks for visiting my video lecture.